In this video, I will revisit the topic of spectral analysis of 2x2 matrices and the efficiency tricks you can use to save time. It is a relatively popular video among my YouTube collection, so I decided to make another one on this topic. The link to the original video is in the description to this video down below. Also, if you like this presentation and if you would like to reuse it in your own class, if you're a tutor or an instructor or a teacher, there's another link in the description below which will tell you how to do this with a minimal effort. Now back to the task. The task we're looking at is finding the eigenvalues and eigenvectors of a 2x2 matrix like this. So I name the entries of my matrix A, B, C, D, and for such matrix we aim to find eigenvalues and eigenvectors. We start off by computing the corresponding characteristic polynomial. This is how we do this. We take the determinant of the combination A takes Z times identity, and we compute such determinant. That's what we do. In order to find such determinant, we multiply the main diagonal and subtract the product of the opposite diagonal. Once you carry out all of the expansions and simplify the similar terms, you will end up with a quadratic polynomial, which is the characteristic polynomial of my matrix of size 2x2. Now we know that the eigenvalues, we know this thanks to Vieta's theorem. The eigenvalues, they are the roots of this polynomial, and thanks to Vieta's theorem, we know that the roots, if you add them, they equal to the coefficient next to the z term with the opposite sign, and if you times the roots, still unknown roots, that will be the free coefficient in your quadratic polynomial. Now these two quantities, the a plus d, if you look what they represent in terms of my original matrix, these are two elements on main diagonal, and AD take BC in relation to the original matrix, that's the determinant of my original matrix. So what I can say now is that the eigenvalues, the unknown yet eigenvalues of my original matrix, they are such that if you add them up, the result will be equal to the sum of the elements on the diagonal, and if you times them, the result will be the determinant of your original matrix. By the way, this quantity, the sum of the elements on the main diagonal, it has a special name. It's called trace of that matrix. A plus D is called trace of the matrix A, and just for completeness, AD take BC is called determinant, trace and determinant. So if I use these two terms, I can say that the sum of the eigenvalues equals to the trace of the matrix, and product of the eigenvalues equals to the determinant of my matrix. This is the efficiency trick you can use to find eigenvalues quickly by stating these two relations and then guessing the eigenvalues. I'll show you this on the example. Here's my matrix 2x2 with integer entries, and we have to solve this task, find eigenvalues and eigenvectors. I will do this by writing up these two relations. The trace of my matrix is sum of the elements on the diagonal, 7 plus negative 8. So the sum of my unknown eigenvalues equals to trace 7 plus negative 8, which is negative 1, and the product of my unknown eigenvalues is the determinant, which is 7 times negative 8 take negative 6 times 9, which if you crunch it is negative 2. Now we can do guessing. Two numbers such that the sum of them is negative 1 and product is negative 2 are relatively easy to guess. One of them is negative 2, the other one is 1. And that's how you quickly can identify the eigenvalues associated with the 2x2 matrix. If you now proceed to the eigenvectors, you do your regular analysis. You find the eigenvectors for each of the eigenvalues. For the -2, you have to compute this matrix z plus 2 identity, which is this matrix 9, 9, -6, -6, and then you have to find a vector, a non-zero vector, in the null space of this matrix. Again, it's a guesswork, and the guess is 1 and -1. That is the eigenvector associated with the value -2. For the second eigenvalue, 1, again, you have to first write up the matrix A take identity, that is 6, 9, -6, -9, and then you have to guess a vector in the null space, non-zero vector, that's important, in the null space of this matrix. The guess is 3, or one of the possible guesses, 3 is -2, so my second eigenvector is 3 and -2. And that's how you find the eigenvalues and eigenvectors for a 2x2 matrix with the efficiency trick based on Vieta's theorem, trace, and determinant. Let me say it again. If you like this presentation and if you would like to reuse it in your own class, you can do it with absolutely minimal effort, and the way to do it is explained in the description to this video.